Okay, part 3 of exam review, or exam 4 review. This will cover all of the story problems. So in any story problem, we need to know what they're asking. How many quarters and nickels does this guy have in his pocket? We don't know how many of each, so we need to have variables. We can let x equal quarters, and we can let y equals nickels, for example, or the number of quarters and the number of nickels. We don't know how many each separate there are, but we know that total number of coins in his pocket is 11. So if we have x and we add y, that's going to equal 11. Since we have two different variables, we need to have two different equations in order to solve for them. Now the total value of his change is $2.15. The total value is found by the value of quarters plus the value of nickels. If the value of a quarter is 25 cents, the total value of all the quarters is 25 cents times how many quarters there are. The total value of a single nickel is 5 cents, but the total value of all the nickels he has in his pocket is 0.05 times the number of nickels he has. The total of both types of coins is $2.15. Now I don't like the decimals here in the bottom equation, so I'm going to multiply this bottom equation by 100. That's going to give me an equation of 25x plus 5y is equal to 215. Now if I multiply the top equation by negative 25 to try to cancel the x variable, this is going to be negative 25x minus 25y is equal to negative 275. Doing the elimination method produces negative 20y is equal to negative 60, which means y is equal to 3. Remember, y is equal to nickels, so y equal 3 is in the solution here. The solution is he has 3 nickels. And if he has 11 coins total, that means he has 8 quarters. Okay, question 17. Admission fee. How many children and how many adults attended the theater? So they're asking about ticket sales. How many tickets were sold to both children and to adults? We don't know how many of each, so we can say x equals the number of child tickets. We could let y equal the number of adult tickets. Separately, we don't know how many tickets were sold, but together it says that 650 movie tickets were sold. So x plus y equals 650 movie tickets. Now the total profit, $4,975, that profit is made by charging $5 per child ticket. Well, there were X child tickets sold. If they're charging $5 per child ticket, then the profit for just children tickets is 5x. The profit for adult tickets is $8 times the number of adult tickets sold. If we add those two together, the total profit is going to be $4,975. Now if I multiply the top equation by negative 5, again to try to cancel x, then this is going to be negative 5x minus 5y equals negative 3250. Bottom equation, 5x plus 8y, $4,975. Performing elimination now gives us 3y equals $1,725. Dividing both sides by 3 gives 575 for y. Y equals the number of adult tickets that were sold in the theater that day. So there were 575 adult tickets. There were 650 tickets total. That leaves 75 children tickets. So 75 child tickets and 575 adult tickets. Okay, 18. First of all, there was a typo. They don't leave their hose, they leave their house. So they both leave their house. Drive. So they live together, and they live, or they drive in opposite directions. 60 miles per hour. For what length of time? They're asking how long each of them drive. We don't know a couple of things. This is one of those distance equals rate times time problems. The only thing we know is each of their rates. John drove for 60 miles per hour. Mary drove 40 miles per hour. We don't know how far they drove or how long it took them. Those two things are unknowns. If we let x equal Mary's distance, then John's distance said John travels 35 miles farther than Mary. If Mary's distance is x, John's distance is x plus 35. Now, what I'm trying to do here is, we don't know the distance or the time for both John and Mary. If we try to make so many different variables, 2 variables for each, there's going to be way too many variables. So what we need to try to do is describe their distances using the same variable and the time that they drove using the same variable. So we only have 2 variables. I'm going to use t for time, and we're using x for distance. So we can let t equal hours that Mary drives. Now the reason I'm choosing to use hours that Mary drives, even though that the minutes they give us is in 15 minutes longer than John's, the rates they gave us are in miles per hour. We have to have the same unit of measure, miles and hours, since that's the rate that was given. So Mary's trip takes 15 minutes longer than John's. So Mary drives for t hours. That means John drives for t minus 15 minutes, which is a quarter of an hour. So t minus 1/4 hours. So for Mary, now what we're going to do is make a distance equals rate times time equation for each person. Mary, her distance equals rate times time equation. Her distance was x, her rate was 40, and the time that she traveled was t. For John, his distance equals rate times time equation. He traveled a further distance. And he also did it in less time. So what we need to do now, let's maybe simplify this a little bit, this equation here. So if I distribute the 60 to the t and then negative 1/4, that's going to be 60t minus 15. But then if I subtract 35, that minus 15 is going to turn into negative 50. So this equation here is x equals 60t minus 50. So that's what this x equals for John. And now if we look up at Mary, her x equals 40t. If x equals 40t, but x also equals 60t minus 50, that means that 40t equals 60t minus 50. If we solve for t in this equation here, we get t is equal to 2.5 hours. Remember, t is how far or how long Mary drives. So if Mary drives for 2.5 hours, John drives 15 minutes less than that. So Mary is 2.5 hours. John then drives 15 minutes less than that, which is 2.25 hours. Okay. This is the linear programming one that linear programming. What they're asking is how many of each model should be produced. And it's not just how many should be produced, but how many should be produced to minimize costs. So their objective here is to minimize costs. We have an objective function. And then each, how many of each, what are we dealing with? We're dealing with standard and scientific calculators. So we can let x equal the number of standard calculators, and we can let y equal the number of scientific calculators. Objective is to minimize cost, so we have to have an objective function. And since they're trying to minimize cost, our objective function needs to describe the cost. Well, it costs $5 to produce a standard calculator, and they produce X number of those. It also costs $7 to produce a scientific calculator. They make Y number of those. So this is the objective function, minimize cost. Okay. What we need to have now are values of X and Y to plug into this cost function to see which produces the minimum cost. And we get those X and Y values off of a graph of the feasible region. Now the feasible region is that bounded region of inequalities that need to be formed based on the information given. So let's just go a sentence at a time. Long-term demand for the two models mandates that the company manufacture at least 100 standard and 80 scientific calculators each day. So, well, the two ones we need to start with obviously are X greater than or equal to 0, Y greater than or equal to 0. They have to produce a positive number of calculators. Now, at least 100 standard calculators. So X is greater than or equal to 100. At least means they have to produce 100 or more, so X is greater than or equal to 100. For Y, that's 80 here, scientific, so Y is greater than or equal to 80. And because of limitations on production capacity, no more than 200 standard calculators can be made daily. 200 standard calculators, which is X. So X is less than or equal to 200. They can't produce any more than 200. For Y, that number is 170. To satisfy a shipping contract, this is the last sentence. To satisfy a shipping contract, a total of at least 200 calculators must be shipped every day. It doesn't specify of what kind, just 200 calculators total. So x plus y, a total or a combination of either one, has to be greater than or equal to 200. Okay, so we have our linear inequalities here. We're going to graph each of these to find our feasible region. Now I'm going to label my axes by 20s. 20, 40, 60, 80, 100 is right here. This is 20, so 20. Okay. This is 200. 100, and that's 200. X is greater than or equal to 100. That's a vertical line coming up from 100, and greater than 100 is in this direction, so we're going to be shading in this direction eventually. And then X is less than or equal to 200 is a vertical line coming from 200, less than or equal to 200 is shading in this direction. So far we have these two vertical opposing lines shaded in the middle region here. Now y is greater than or equal to 80. That's a horizontal line going through 80. Greater than, that means we're shading above. So we're shading above, but it has to be less than or equal to 170. So 170 is right here. So we're shading below that line. So far the region that contains all the shades is this region in here, this rectangle right in here. If we can keep track of all this. There's one more we need to graph. X plus y is greater than or equal to 200. That means the x and y intercepts are 200. The line connecting those like that. And then if we use our test point of 0, 0, if we're testing what we need to know is where we shade on this diagonal line I've just drawn. If x and y are both 0, we end up with 0 greater than or equal to 200, which is not true. 0 is not greater than or equal to 200. So we're not shading towards the test point on this line, we're shading above this line. So now we have our feasible region as this region right here. So what we need to figure out now are the edges or the corners of this feasible region. We have one right here, right here, we need to find out which of these vertices minimize the cost. So we need to know the location of each of these vertices. This location here is 100, 170. This vertex here is 200, 170. This vertex here is 200, 80. Now we need to know the location of these two vertices. Now this vertex here, we know that the y value, since this point is on this line right here, this line represents y equals 80, so we know at least the y value of that point is 80. And this diagonal line that's drawn, this is the line x plus y equals 200. Well, if x plus y equals 200 and y is 80, that means x has to equal 120. We can use a similar argument here for this point. This point is on the line x equals 100. but that point is also on the line x plus y equals 200. And if x is 100 and x plus y equals 200, that means y is also 100. So what we need to figure out then is the cost of production at all of these points here. So cost at each vertex. So the cost of this one, 200 and 170, comma 170. If I take 200 for x and 170 for y and plug it into our cost function, that's going to give us a cost of $2,190. This one down below at 280, 200 comma 80, 200 comma 80. If 200 standard calculators were made and 80 scientific calculators were made, that's a cost of $1,560. If this vertex right here, 120 comma 80, if we have 120 standard and 80 scientific, that's a cost of $1,160. This vertex here, 100 comma 100, 100 comma 100. If 100 of each are made, that's a cost of $1,200. And this one here, 100 comma 170. That's going to be a cost of $1,690. So according to this, to minimize production costs, it's that combination right there. Minimum cost, minimum production is to make 120 standard calculators and 80 scientific calculators. Okay. How many servings of each food should Nicole eat? There's 3 different types of food: toast, cottage cheese, and fruit. And we need to know how many servings of each. This is going to involve 3 variables then. X equals the servings of toast. We can let y equal the number of servings of cottage cheese, and then we can let z equal the servings of fruit. Now there's a lot that's happening in this problem here. Her diet requires that she has 460 calories, 6 grams of fiber, and 11 grams of fat. So we can make an equation for each of these different types of daily requirements, or an equation that describes how many calories she needs. We can start with that one. She needs 460 calories. Okay, the number of calories that she...
Teacher, sorry for the interruption. There is a maroon car with the license plate V903YX that is in the bus zone on the south side of the school. It needs to be moved immediately.
So the number of calories that she has in a day depends on the number of servings of each of these foods that she has, and the number of calories that are in each type of food. And it says here, a serving of toast, which is X, the servings of toast has 100 calories. So it's 100 calories times how many servings of toast that she has. Okay, a serving of cottage cheese has 120 calories, so she gets 120 calories times the number of servings of cottage cheese that she has. And then calories from fruit, 60 calories times the number of servings of fruit. Now let's do the same thing for fat content. She needs to have 11 grams of fat. From toast, she's going to get 1 gram of fat per serving. From cottage cheese, she's going to get 5 grams of fat per serving Y. And then for fruit, she's going to get 0 grams of fat per serving. So that's 1x plus 5y. Now for fiber, her diet requires her to have 6 grams of fiber. So from toast, she's going to get 2 grams per serving. From cottage cheese, she's not getting any grams of fiber. So there is no y variable there. And then from fruit, she's going to be getting 2 grams of fiber. So this is a system of equations now that can be solved using either elimination method. You could turn it into an augmented matrix and solve it using Gaussian elimination. There's a lot of different ways that you could solve this. The easiest one probably being the elimination method, like has already been shown. I think the hardest part of this problem was the setting up of the problem. Solving it shouldn't be that bad. It turns out that x is equal to 1, y is equal to 2, and z is equal to 2. What this means is she needs 1 serving of toast, she needs 2 servings of cottage cheese, and she needs 2 servings of fruit.